A component in Angular has a life cycle, a number of different phases it goes through from birth to death. By the end of this lecture, we're going to understand the different phases an Angular component goes through from being created to being destroyed. You're going to know how to hook into those phases and run your own code. And you're going to know the order in which those different phases happen and what triggers each phase. So we can hook into those different phases to get some pretty fine-grained control of our application. To do this, we need to add some specific methods to our component class, which get called during each of these lifecycle phases. We call those methods hooks. And the hooks are executed in the order you see on the screen. And the phases are broadly split up into phases that are linked to the component itself and phases that are linked to the children of that component. So the yellowish green color are the phases that are linked to the children, and the pink and blue color are the phases linked to the component itself. So the constructor, this is invoked when Angular creates a component or directive by calling new on the class. Then we have ng on changes, and this is invoked every time there is a change on one of the input properties of the component. Then we have ng on init, and this is invoked when a given component has been initialized, and the hook is only called once after the first ng on changes, whereas ng on changes is called every time there is a change on any of the input properties. And then we have something called ng do check, and this is invoked when the change detector of the given component is invoked. It allows us to implement our own change detection algorithm for the given component. And just a quick note, you shouldn't implement do check and on changes on the same component. And then we have ng on destroy. So this method will be invoked just before Angular destroys the component, and use this hook to unsubscribe from things like observables or detach event handlers, and it's just there to avoid memory leaks. So those are the hooks for the component itself. Let's have a look at the hooks for the component's children. So these hooks are only called for components and not directives, and we'll go through what a directive is in the next section. Then we have ng after content init, and this is invoked after Angular performs any content projection into the component's view. Then we have ng after content checked, and this is invoked each time the content of a given component has been checked by the change detection mechanism of Angular. Then we have ng view init, and this is invoked when the component's view has been fully initialized. And then we have ng after view checked, and this is invoked every time the view of the given component has been checked by the change detection mechanism of Angular. And we're going to dig into these children hooks in more detail in the next lecture. So in order to demonstrate how hooks work, we'll just adjust the joke application we've been working with so far. Firstly, let's change the joke component so it hooks into all the phases. And to do this, all we need to do is to add functions to the component class matching the hook names. So I'm going to copy and paste this code in to our joke component. So we've got the constructor, ng on changes, ng on init, do check, after content init, after content checked, after view init, after view checked, and ng on destroy. So we also need an easy way to trigger these hooks. So let's change the rest of the application. We remove the form and then change the parent joke list component so it has two buttons, one that adds a joke, triggering Angular to create a new joke component instance. Another button is to clear the list of jokes, triggering Angular to delete the joke components. And finally, we need to initialize the jokes to an empty array. And now let's run our application. We have two buttons, add joke and clear jokes. If I click add joke, it adds a joke to the list. If I click clear joke, it clears the jokes from the list. So let's open up the console and see what it prints out. Clear those. So if I add a joke, then a joke is added to the list and Angular creates an instance of the joke component, triggering the lifecycle hooks. And as you can see, for the first three hooks, we're also printing out the value of the joke's input property. So we're also printing out the value of this input property here. And we can see in the constructor that input property is undefined. However, by the time the ngOnChanges hook is called, we can see that the input property is now set to, well, you can trust me, it's set to the joke. And this leads to an important note. The best place to initialize your components is in the ngOnInit hook and not the constructor, because only at this point have any input property bindings been processed. The reason we use ngOnInit and not ngOnChanges to initialize a component is that ngOnInit is only called once, whereas ngOnChanges is called for every change to the input properties. And when we press clear jokes button, Angular deletes the joke component and calls the ngOnDestroy hook, which we can see in the log. So we can actually tap into the exact changes to the input properties by examining the first parameter to the ngOnChanges function, which we typically call changes. And the type of this changes argument is a map of the input property name to an instance of something called simple change. So we change our ngOnChanges function to take the changes argument and loop through it to print out the simple change. And we need to remember to import simple change in. So let's go to the top. And again, it's from Angular core. So let me add that in from there. Scroll down to the bottom. Back to ngOnChanges, there we are. And I'm just going to paste some code in to save time. So we're going to use the for in loop to loop over each key in the changes map. And for every key, we're just going to log out the key. And then to get the current value of the input property, we call .currentValue. And to get the previous value, we can use .previousValue. So now if we run the application again, add a joke. Then let's look at the console. You can see here we go. On the ngOnChanges function, we got printed out the current value, which is just a joke object. But then the previous value is set to something called cdInit value. When no value has been set for an input property, it gets defaulted to the string cdInit value, rather than the values null or undefined. So in the sample code so far, we are just defining the hook functions directly on the class. But we can take advantage of a feature of TypeScript interfaces and be more explicit regarding our intentions. Each of these lifecycle hooks has an associated TypeScript interface of the same name, but without the ng prefix. So ngOnChanges has an interface called onChanges. Each interface defines just one hook. And by making a class implement an interface, we are saying we expect the class to have implemented that member function. If it doesn't, then TypeScript should throw an error. So first of all, let's import all of the interfaces that we need. So I'm going to import them at the top of our file. And actually, we're getting quite a lot of imports here. So let's just make them span multiple lines. And then let's add all of the imports that we need for our interfaces. And then if we go back to our joke component, if you remember from the section on TypeScript, to make a class implement an interface, we use the implements function. To make a class implement an interface, we use the implements keyword. So I'm going to make it implement all of those interfaces we've just imported in. There we go. So now we've implemented these interfaces on the joke component. If, for instance, we removed ngOnInit, TypeScript would then complain because we've implemented the onInit interface, but we're not implementing the ngOnInit function that's defined in the onInit interface. So implementing interfaces is just a really good way of clearly expressing your intentions and then making sure you follow through with them. So in summary, using lifecycle hooks, we can fine-tune the behavior of our components during creation, update, and destruction. We use the ng-on-init hook most often. This is where we place any initialization logic for our component. It's preferred over initializing via the constructor, since in the constructor, we don't yet have access to the input properties, whereas by the time ng-on-init is called, they have been bound to and are available to use. ng-on-changes is the second most common hook. This is where we can find out details about which input properties have changed and how they have changed. And the third most common hook is ng-on-destroy, which is where we place any cleanup logic for our component. That's it for lifecycle hooks. In the next lecture, we're going to cover an advanced topic of components called view children and content children.